Okay, welcome back. This is lesson 1.2, notes on adding integers. We are going to be adding integers using number lines and then also checking our work with other methods, including the acronym SADS. So looking at number 1 here, we have 4 plus negative 4. Remember that we start at 0 and go to our first number. We're going to put a point there and go out to our first number here, the 4. And then we'll put a dot right above it to go to our next number. We have a plus negative 4, so that means we're going towards negative 4 or in the negative direction 4 units. So coming right back 4 units, and where we land is 0. So our answer is 0, and that makes sense because 4 and negative 4 are a 0 pair. In other words, opposites add up to 0. So any number and its opposite equals 0. Okay, let's take a look at part B. This time we have negative 1 plus negative 3. So we starting at 0, we're going to go to our first number, negative 1. And then we'll start our next arrow. We are going towards the negatives 3 units. So we're going to count out 3. 1, 2, 3. And where we land is at negative 4. So to test and check our work, we know that same signs add, and then we keep the sign in common. If you have a negative plus some more negatives, you just have a total of more negatives. So thinking back to our integer chips, if we have negative 1 plus negative 3 all together, the same signs would add, and we would keep our sign. Okay, there are no 0 pairs to cancel there. So that's why we have a total of negative 4. Okay, we have question C. Here we have a negative 2 plus positive 6. So we're going to have different signs. Starting at our first number, we're going to go to 0 and out to negative 2. And then we'll place a point on the top of that and go towards 6 positives. So we'll go out 2 here. And then you can count it out 3, 4, 5, 6, so that we're going a total of 6 units. And that puts us at positive 4. To review, when we have different signs, we take their difference. And difference is just another word for subtract. So if we did 6 minus 2, okay, that's 4, and we have more positives. So our answer, okay, positives wins. Our answer is positive, and that's why it's positive 4. When you take their difference, the sign with the larger absolute value is the sign of your answer. And that makes sense. If we go back to checking with our integer chips, we have 2 negatives and we have 6 positives. 1, 2, 3, 4, 5, 6. And we're combining them. We can see that this positive and negative chip is a 0 pair. This positive and negative chip is a 0 pair. And that's how we're left with the 4 positive. All right, I want you to pause this video for a moment and then turn the page and try the other 3 examples using number lines and then also checking your work. Okay, welcome back. If you just completed pausing and working out these number lines and finding the sum, we are going to check our answers together right now. So we have negative 2 plus 2. Well, we know that that's a 0 pair, but to show it on our number line, we're going to start at 0, go out to our first number, the negative 2, and then we're going towards 2 positives, so we're going to come right back 2 units, and that's how we get 0. Okay, modeling number 2, we're at positive 4 first, so starting at 0, we're going to go out to 4, and then we're going towards the negatives 5 units. So we're going to go out 4 and one more for 5 in this direction. And that gives us -1. And yes, different signs subtract, so we know their difference is 1. And we have more negatives, so our answer is -1. Okay, here we have the same sign, and they're both negative. We have a -3 plus another -3. So we're going to start at 0 and go to our first number, the -3, and then we're going to go towards 3 more negatives. So count that out, 1, 2, 3. And we get -6. And same signs add, and we keep the sign. So we have -3 plus -3 is altogether -6. All right, some key ideas to remember, rules for adding integers with the same sign, is that same signs add, and then you're going to keep the common sign. If they're both positive, your sign will be positive. If they're both negative, your sign will be negative. The additive inverse property. The additive inverse property, we have the word inverse there, means that a number and its opposite equals 0. So any number plus its opposite is going to be 0. And that's our idea of the 0 pairs. Okay, adding integers with the same sign practice. Here, example number 2, we have -4 plus -2. That's altogether -6. I'm going to add and keep the sign. Go ahead and try the next 3 questions. Click pause, and then when you come back, you can check your answers. Okay, welcome back. We have 2 positives here, so the same sign is going to add, and we're going to keep our sign, but we don't usually put a positive sign there. If it's 7 plus 13, that's just 20. Example number 5, we have 2 negatives, so again, same signs add, and this time we're going to keep the negative. So -5 plus -8 is altogether -13. And in number 6, we have -2 plus -15. Well, that's -17. Same thing, we're going to add and keep that sign. All right, let's turn it over. Rules for adding integers with different signs. Okay, for different signs, think of the word difference. Different and difference. Okay, so we're going to subtract their absolute value. And then the sign with the most wins. If you have more positives, your answer will be positive. If you have more negatives, your answer will be negative. Let's take a look at example number 3, adding with different signs, part A. We have 5 plus -10. Well, if I take their difference, my answer will be 5. And I have more negatives than positives, so my answer will be -5. Finding -3 plus 7 for part B. This time I have more positives. If I take their difference, 7 minus 3 is 4, and my answer is positive because I have more positive. Part C, we have 12 plus -12. Well, 12 and -12 are a 0 pair, so they're going to add up to 0. They're the same. So this is a 0 pair. Here we had more negative. Here we had more positive. Okay, pause and try the next 3 questions, and then come right back. Okay, welcome back. -2 plus 11, we're taking their difference, which is 9, and our answer stays positive because we have more positive. 9 plus -10, well, if I take their difference, I get 1, but I have more negatives, so my answer is -1. And then for number 9, I have -31 plus 31. Well, opposites add up to 0. That is our additive identity property. And so that's just 0. Let's take a look at a word problem, modeling real life. We have some July transactions here. It says the list shows 4 account transactions. Find the change in the account balance. Find the sum of the transactions. So we'll notice that with withdrawals, there's the negative sign. That means you're taking money out. And deposits are positive because there's no sign in front, and that means that you're putting money in your account. So we have 2 negative signs or amounts that were withdrawn and 2 deposits. The easiest way to get the sum of all of these numbers is to reorder them so that you're adding your negatives together, adding your positives together, and then taking their difference. So what I'm going to do is I'm going to write -4 plus -50 plus 50 plus 75. And actually, I already see a 0 pair there. I see my -50 and 50, so I could just cross them out, and then I would take the difference of these two numbers. As a matter of fact, let's just do it that way. Another way you could do this would be to lump your negatives together. That would be a total of -90. And if you added your positives together, that would be a total of 125. But I like when I see 0 pairs to just cancel those numbers out, because we know that -50 plus 50, they cancel each other out. If you put $50 in your account and then you take the $50 out, it's almost like you didn't put it in there. So now our math problem is -40 plus 75. Different signs subtract. 75 minus 40 is 35. And we have more positive. So luckily we have a balance there of money in the account. We don't owe the bank any money. 35, we're going to represent that with money. So that's $35. Okay, go ahead and read question 10 and try to work that one out. Okay, welcome back. We have a word problem here. You are hiking. The trail begins at an elevation of 8,136 feet. First you go down and then up, and then you go down and then you go up. What is the elevation at the end of the trail? So we're starting at this elevation. So we're going to start with that number. That's 8,136. So we're going to add up all of our ups and all of our downs together, because we want to know how much we're going up and how much we're coming down, and then take their difference. So this one says down 174 and then up 350. So we'll add the 350 here. And then down 180. This is our down. And then up 282 feet. And then what is our elevation at the end of the trail? So taking our sum of all of our positives here, lining up our numbers, we have 8. 8 plus 8 is 16. Carry the 1. 5, 6, 7, and 8. So we have 8,768 feet elevation. And then coming down or descending, we have 7 and 7 is 14, 15. Carry the 1. But remember that this is down, so this is actually -354. So we're going to add these two numbers together, our 8,768 and our -354. So different signs subtract. And then we're obviously going to have more positive, so positive is going to win. Okay, 8 minus 4 is 4, 6 minus 5 is 1, 7 minus 3 is 4, and 8 minus nothing is 8. So our elevation at the end of the trail is at 8,414 feet. Once you're done with your notes, you can put this in your notes section of your binder.